Rechlin Airfield, Germany. Late autumn 1943. The hangar was silent except for the faint ticking of cooling metal. Under a pale afternoon light, a group of German engineers stood around the wreckage of a captured American fighter, its silver fuselage scorched, but its heart intact. The engine, still glistening with oil, looked impossibly large, each cylinder the size of a man's forearm. Heavy steel pipes curled like veins around its round, brutal shape. A Luftwaffe officer stepped closer, brushing off dust from the cowling. Stenciled letters read, Pratt Whitney R 2800, 2,000 horsepower. They had seen reports of this machine, the American P-47 Thunderbolt, a brute of an aircraft that climbed like a rocket and dove like a stone. Pilots called it indestructible. Mechanics said it could take bullets and keep flying home. But now, seeing it up close, the disbelief settled into unease. The Germans prided themselves on precision, on perfection through craftsmanship. Yet this engine was something else, mass-produced perfection. Every component standardized, rugged, built for thousands. No wonder it never quit. In that quiet hangar, surrounded by Allied steel and their own sketches, they realized how far behind they had fallen. When the Second World War began, the sky belonged to Germany. In 1940, the Luftwaffe was the most advanced air force on Earth. Its fighters, sleek Messerschmitt Bf-109s and rugged Junkers bombers, cut through the air over France and the Low Countries like surgical instruments. Precision, efficiency, and speed defined the German way of war. The Blitzkrieg had rewritten modern combat, and the Luftwaffe was its spear point. In those early years, Germany's engineers were confident. Their aircraft were light, fast, and mechanically elegant, handcrafted machines designed for short, decisive campaigns. They were built to dominate the skies over Europe, not to sustain years of attrition. And that would soon matter. Across the Atlantic, the United States was still neutral, still watching. But its aviation industry was transforming, quietly, methodically, into something the world had never seen before. Where Germany relied on perfection by experts, America relied on production by thousands. In 1941, after Pearl Harbor, the sleeping giant woke. Factories that once built cars began building fighters. Assembly lines that had produced Chevrolets now produced P-47s, P-38s, and B-17s. It wasn't artistry. It was arithmetic. The Luftwaffe's philosophy was rooted in finesse, aircraft optimized for speed and agility, with tightly engineered inline engines and lightweight frames. American design thinking was entirely different. Power first, reliability second, simplicity third. To a German engineer, an American engine seemed crude. Oversized bolts, heavy casings, minimal machining. But the Americans weren't building for show, they were building for endurance. By 1943, the difference in design philosophy began to show in combat. German aircraft could still outturn and outclimb at low altitude, but Allied planes were beginning to survive hits that should have torn them apart. Reports from the Eastern Front and North Africa were already worrying the Luftwaffe command. Allied planes kept coming back. The reason wasn't just armor or tactics, it was engines that could take punishment and still deliver full power. The key lay in America's approach to production. Every major component of a U.S. fighter, from its propeller blades to its spark plugs, could be replaced within hours, anywhere in the world. Factories shared standardized parts, blueprints, and materials. Engines were built not by a handful of craftsmen, but by assembly line workers trained to build thousands identically. This system, driven by industrial titans like Pratt & Whitney, Allison, and Wright, produced engines with reliability rates that stunned the Germans. While the Luftwaffe still inspected every block by hand, the Americans tested by statistics and found that consistency could outperform perfection. Meanwhile, U.S. bombers began flying deeper into occupied Europe. The Luftwaffe's pilots faced aircraft that didn't falter under stress, didn't overheat, didn't quit. And when those bombers started flying with escorts, the P-47 Thunderbolts, German confidence began to erode. The first P-47s appeared over France in spring 1943. Massive, heavy, almost inelegant compared to the Messerschmitts, they looked like flying tanks. Luftwaffe pilots scoffed until they fought them. German combat reports soon described an enemy aircraft that climbed beyond interception, dove faster than anything they'd seen, and could withstand damage that would have shredded a 109. Pilots fired long bursts, hit fuel lines, and watched the Thunderbolt simply keep flying. At first they assumed luck, then repetition made it undeniable. By late 1943, the Luftwaffe had shot down enough P-47s to recover several relatively intact wrecks. One was transported to Rechlin, Germany's central aviation testing ground. There, the engineers would discover the secret that had haunted their pilots for months: a 2,000-horsepower R-2800 double Wasp engine that defied everything they thought possible in a radial design. It was heavy, yes, but unbreakable. Simple, yes, but efficient at altitude. And above all, it could be mass-produced. What they saw inside that American machine would redefine their understanding of what industrial warfare had become. It was never supposed to be graceful, the Republic P-47. Thunderbolt was a monster of a fighter, nearly 20 feet long, weighing over 8 tons fully loaded, with a wide, barrel-like fuselage and a blunt nose packed with engine and armor. Compared to the sleek German Bf-109 or the nimble FW-190, the P-47 looked awkward, oversized, and overbuilt. But looks deceived, because under that thick skin was the most powerful, rugged, and technically advanced piston engine of the war. The Pratt Whitney R 2800 double Wasp, a twin-row, 18-cylinder radial engine capable of delivering over 2,000 horsepower, even at 30,000 feet. The Germans weren't ready for it. In 1940, as the United States watched the war escalate in Europe, a team of engineers at Republic Aviation, led by Alexander Kartveli, an émigré from Georgia, was already thinking ahead. They knew the next war would be fought at altitude, at range, and with firepower. Kartveli's vision was blunt. Make it big. Make it powerful. Make it survive. The P-47 was designed around the R-2800 engine from the beginning. But it wasn't just raw horsepower that made it extraordinary. It was the turbo supercharging system that delivered full power at high altitude, long after most engines gasped for air. This system, with ductwork running through the rear fuselage to a separate turbocharger, was bulky and complex. But it worked, and it gave the P-47 a critical edge in climb rate and top speed at high altitudes. In testing, the Thunderbolt broke 430 km/h faster than any German fighter in level flight at the time. In a dive, it was nearly unstoppable. And with its thick airframe and rugged engine, it could absorb terrifying damage and still make it home. The P-47 first entered combat in spring 1943, flying out of airfields in England with the 8th Air Force. Initial results were mixed. Pilots found it heavy and hard to maneuver in tight turns. But soon they began to exploit its real strengths: high-altitude escort, deadly diving attacks, and near-total survivability. Its 850 caliber machine guns could tear apart fighters or ground targets. Its engine could run on low oil pressure. Its air-cooled radial design made it resistant to coolant loss, a death sentence for many inline German engines. And when German pilots tried to follow a P-47 into a dive, they often never came back up. The Thunderbolt could reach Mach 83 in a dive, speeds that sent 109s into compressibility stalls and catastrophic failures. By the summer of 1943, Luftwaffe squadrons along the Western Front were facing squadrons of Thunderbolts escorting B-17s deep into occupied territory. Intercept missions became more dangerous. Reports of failed attacks increased. Field intelligence began to take note. Ground crews salvaged wrecked Thunderbolts and passed fragments to Luftwaffe technical departments. Observers were baffled by the design. the sheer size of the propeller, the ducting system, the thickness of the cockpit armor. Then came the first major prize, a mostly intact P-47 forced down in France in late 1943. Its pilot survived, but the aircraft was captured with minimal structural damage. It was quickly shipped by rail to the Luftwaffe's Central Test and Evaluation Center at Rechlin, north of Berlin. This was where Germany's most advanced minds, engineers, test pilots, analysts dissected enemy technology. The Thunderbolt was about to face the German microscope, and what they found shook them. The R-2800 engine was like nothing they had worked with. Each cylinder head was overbuilt for pressure. The casing was thicker than needed. Redundancy systems, oil lines, magnetos, fuel pumps were doubled up. Even the starter system was modular. It was the opposite of German engineering philosophy. Where they shaved grams, the Americans added strength. Where the Germans saw waste, the Americans saw survivability. Even more alarming, every component was serial stamped and interchangeable. No hand-fitted parts, no precision tuning. It was a factory-built beast, engineered not for one aircraft, but for thousands. To German minds, it was industrial madness. Then they read the specifications. 2,000 horsepower, a turbocharger that worked flawlessly above 25,000 feet. And an engine that could be mass-produced, not in secret hangars, but on Detroit assembly lines. When German engineers finally laid hands on the Pratt Whitney R 2800 double wasp, their first impression was disbelief. It was massive, coarse, overbuilt. It didn't resemble the refined lines of the Daimler-Benz DB605 or the BMW 801, Germany's top inline and radial engines. The double wasp looked almost agricultural in comparison. But that impression faded the deeper they went. What they found was not crude, it was purposeful. German engines were finely tuned. The DB605, which powered many Bf 109 variants, delivered up to 800 horsepower with sophisticated mechanical superchargers and complex cooling systems. But it was fragile, prone to overheating, and difficult to maintain in the field. The R-2800, on the other hand, was air-cooled, eliminating the vulnerability of liquid radiators. It ran hot and didn't care. Its thicker cylinder walls and redundant oil systems meant it could survive coolant loss, oil leaks, and even partial cylinder failure. It didn't need delicacy. It needed to keep going, under fire, in the cold, with a rookie mechanic at a muddy forward base. That made it terrifying. The second revelation was in the turbo supercharging system. German engines primarily relied on mechanical superchargers, compact, gear-driven compressors that added power at altitude. But these had limits. Their boost faded above 20,000 feet, and their complexity made maintenance harder as war conditions deteriorated. The R-2800 in the P-47 was paired with a GE-designed exhaust-driven turbocharger located behind the cockpit. Exhaust gases flowed through long ducting into a turbine, which drove a centrifugal compressor. It was bulky, yes, but it worked brilliantly. At 30,000 feet, the Thunderbolt's engine still delivered full power. It could outclimb and outrun many German interceptors, especially once they lost boost at high altitude. For German engineers used to optimizing for the low to mid-altitude combat of the Eastern Front, this was a jarring realization. The Americans were building for the stratosphere. Performance wasn't just about the engine, it was about what fed it. The US used 100-octane aviation fuel, enhanced with tetraethyl lead. This allowed higher compression ratios and boost levels without knocking, something Germany struggled to replicate at scale. Inside the R-2800, metallurgical choices told a deeper story. The Americans had access to high-grade alloys, thanks in part to secure supply lines and vast industrial capacity. Cylinder heads were forged for strength under high temps. Components were designed for modular assembly, not perfection tuning. German engines, by contrast, were labor-intensive. Many components were precision-machined and hand-fitted. Effective but unsustainable as Allied bombing crippled German industry. That disparity meant more than numbers. It meant that while German planes grew more advanced, they also grew more vulnerable. The Allies, meanwhile, were sending thousands of good-enough aircraft that could be repaired in hours and flown again. And no American engine symbolized that mindset better than the R-2800. In the hands of pilots, the R-2800 gave the P-47 a set of tactical tools no Luftwaffe fighter could match. Dive speed. The Thunderbolt could dive safely at over 500 mph, using its mass and power to escape or attack with impunity. Bf-109s and FW-190s risked structural failure at similar speeds. Energy fighting. The P-47 thrived in vertical maneuvering, using power to climb, dive, and retain speed. German fighters struggled to match these energy tactics, especially in longer engagements. Damage resistance. Even when riddled with 20mm shells, Thunderbolts often returned. Its radial engine could absorb incredible punishment. In contrast, a single coolant leak could end a German fighter's flight. Operational reach. With drop tanks and efficient cruise settings, the P-47 could escort bombers deep into Europe, a role that forced the Luftwaffe into constant, costly interception battles. This wasn't just an aircraft. It was a mobile weapons platform powered by a machine that symbolized American scale, design, and doctrine. And that realization, slowly forming in the minds of German analysts, was more terrifying than any single dogfight. The engineering reports were technical. Tables, tolerances, temperature thresholds. But the emotion behind them was clear, a growing sense of alarm. Because for the German engineers who studied the P-47's engine, the real shock wasn't its design. It was what the design meant. The first question Luftwaffe analysts asked after disassembling the R-2800 wasn't, "How does it work?" It was, "How many of these do they have?" The answer staggered them. By late 1943, over 10,000 R-2800 engines had already been built. By the end of the war, that number would exceed 125,000. Germany, even at peak production, could not match that pace. Engines like the DB603 or Jumo 213 were built in the low tens of thousands, and only in small batches, often modified per aircraft type. Quality was high, consistency was not. What stunned German engineers most wasn't that the Thunderbolt's engine was better in some ways. It was that it was mass-produced to that level of quality, and that hundreds more were arriving every week. This wasn't just engineering superiority. It was industrial dominance. In German aviation culture, the engine was sacred. Each one was a finely tuned instrument assembled with care and expertise. Maintenance crews were elite technicians. Manufacturing was centralized and controlled. The American engine, by contrast, was a product, robust, modular, and engineered for replacement. Parts were interchangeable, repairs were field level. Nothing required a master craftsman. To German minds trained in precision, this felt wrong. But as war dragged on and supply lines stretched thin, the value of rugged simplicity became clear. This disconnect wasn't just mechanical, it was philosophical, and it led to a painful truth. The Luftwaffe had optimized for the wrong war. Pilots had long suspected the Americans were gaining an edge in durability and firepower, but now their mechanics and engineers were confirming it in black and white. By early 1944, Luftwaffe maintenance units were struggling with attrition, spare part shortages, and aircraft that demanded constant servicing. Many German fighters spent more time grounded than in combat. Meanwhile, Thunderbolts kept flying, again and again. Damaged planes were patched with prefab panels. Engines were swapped in hours. Fuel quality remained high. As one German technician wrote in a confidential evaluation, "The enemy aircraft is not superior by invention, but by volume. They make power expendable. We make it irreplaceable." The psychological blow was profound. If the Germans lost a squadron's worth of Bf-109s, it might take months to replace. For the Americans, it was just another delivery from a Michigan factory. German high command had long assumed that the Allies, particularly the Americans, lacked the technical sophistication of the Reich. They saw American mass production as quantity over quality, a sea of mediocre machines. But the P-47 challenged that belief. It wasn't just powerful, it was technically sophisticated, strategically engineered, and tailored to fit a broader warfighting doctrine that emphasized range, endurance, and sustainability. German planners had built for short, intense conflicts, blitzkrieg in the air. They had not built to withstand multi-year global warfare against an enemy who could build faster than they could destroy. This became clear when the P-47 began to dominate the skies, not just as a fighter, but as a multi-role strike platform. Thunderbolts, strafed railways, shredded supply columns, and crippled bridges. Even if German pilots downed one, more would follow, bigger, better, and in greater numbers. And the Luftwaffe had no answer. At first, they had laughed. German pilots described the P-47 as too heavy, too blunt, too sluggish in a dogfight. They joked that it flew like a milk truck with wings. But by 1944, no one was laughing. P-47s were everywhere, diving from the clouds, tearing through flak, returning home with holes in their wings and oil on their cowling, and flying again the next day. And deep in a hangar at Rechlin, engineers stared at a stripped-down R-2800 block and understood the scale of the problem. They hadn't just been out-engineered, they'd been out-industrialized. And in a war where machines decided momentum, that gap was growing by the day. By late autumn 1943, the captured P-47 Thunderbolt had arrived at Rechlin, Germany's central Luftwaffe testing facility. This was where the Reich dissected the weapons of its enemies. British Spitfires, Soviet Yaks, and even early American P-40s had all been flown and examined here. But the P-47 was different. It was not a prototype. It was a mass-produced combat aircraft, shot down intact during a mission over France, complete with engine, armament systems, fuel lines, and radio equipment. The damage was minimal. The engine, the heart of the beast, was fully intact. Now Germany's most senior test pilots and engineers would see what had stunned their front-line units. Luftwaffe engineers began by removing the cowling. The radial engine underneath was daunting. 18 cylinders in 2 rows, packed tight, and protected by heavy firewall plating. The Pratt Whitney R 2800 revealed itself to be ruggedly modular. External oil lines were reinforced. The ignition system was fully redundant. Each cylinder could be individually serviced. The plug leads were neatly arranged and labeled, optimized for mechanics, not machinists. To the German eye, it looked almost crude. But as they traced each line and measured each tolerance, they found something far worse than crudeness. They found resilience by design. Everything about the engine had been made to survive stress. The cooling fins, the oil routing, the baffling systems, all designed to keep the engine running even when shot, starved of maintenance. Worse, they saw it had been built for replacement. The Thunderbolt's entire power plant could be swapped out in less than 8 hours with minimal tools. German aircraft, especially those with inline engines like the DB605, often required days to perform similar operations. It was a lesson in applied logistics. As they moved into the rear fuselage, the engineers encountered the second shock, the General Electric turbo supercharger system. Mounted behind the cockpit and connected via long ducts to the engine's exhaust and intake manifolds, the system was complex in layout, but astonishing in function. German fighters used mechanical 2-stage superchargers, which worked well at medium altitudes. But the turbocharger, driven by exhaust gases, had no mechanical drag on the engine and allowed consistent power up to 30,000+ feet. Here was the secret behind the Thunderbolt's brutal high-altitude performance. It could escort bombers at altitudes Luftwaffe interceptors struggled to reach and retain full combat power while doing so. The Germans had experimented with turbochargers before the war, but they were too complex, too hot, too demanding on materials. By 1943, Germany lacked the metallurgy to build them at scale. And yet, here was an American fighter with one installed as standard equipment. The Germans documented it, sketched it, analyzed its pressure curves, and then they quietly admitted they couldn't copy it. To complete their evaluation, the P-47 was made flight-worthy. A Luftwaffe test pilot, Hauptmann Hans-Werner Lerche, took the controls for a series of test flights under tight security. His flight report was illuminating. At takeoff, the engine delivered thunderous acceleration. The controls were heavy but stable. Once airborne, the aircraft felt overbuilt, like it could tear through the sky on momentum alone. In climbs, the turbocharger performed flawlessly. The engine never lost power above 25,000 feet. In dives, the aircraft accelerated with frightening ease, and unlike many German fighters, retained control authority. In a shallow dive, Lerche pushed the P-47 to Mach 080, brushing against compressibility effects. He recovered cleanly, something Bf-109 pilots could rarely do at such speeds. He noted the cockpit armor, the visibility, and the gun platform's stability. His conclusion was blunt. It is not agile, it is not refined, but it is invulnerable, a flying fortress in single-seat form, and our aircraft cannot outlast it. When the full technical evaluation was compiled in late 1943, it circulated through Luftwaffe technical bureaus and command staff. The tone was unusually sober. Key conclusions. The engine can be produced at scale. Its modularity is a strategic threat. The turbo supercharger provides altitude advantage we cannot match without rare alloys. Pilot protection is exceptional. Survivability from gunfire is significantly enhanced. Combat capability persists even with serious mechanical damage. The report warned that the US could mass-produce aircraft of this type faster than Germany could down them. Some called it alarmist, but frontline units had already begun to feel the truth of it. The Luftwaffe tried to adapt. They rushed new interceptors like the Ta-152 and Me-262, but they arrived too late, in too few numbers, with too few trained pilots and too little fuel. The Thunderbolt, powered by the R-2800, became a symbol of Allied momentum, not just in the skies, but in factories, fuel depots, and airfields across the globe. For every one that was shot down, 3 more were en route. And the Luftwaffe, now on the defensive, began to run out of answers. And time. By early 1944, the U.S. Army Air Forces had fully embraced the P-47 Thunderbolt, and its battlefield presence began to transform the war in the air. Wherever the American bomber stream went, Thunderbolts followed. And wherever Thunderbolts flew, the Luftwaffe began to disappear. The Luftwaffe had once ruled the skies over France and Germany. Their fast-climbing Bf-109Gs, aggressive FW-190As, and lethal 20mm cannons had ripped apart Allied bomber formations for years. But the Americans had a problem. Their bombers could hit Germany, but their early fighters couldn't reach Germany and come back. Enter the P-47, outfitted with external drop tanks. With range extended beyond 600 miles, Thunderbolts began escorting B-17 flying fortresses and B-24 Liberators deep into Nazi territory to Regensburg, Schweinfurt, and Berlin itself. At 25,000 feet, they kept pace with the bombers. At 30,000 feet, they still had power to fight. And when German fighters tried to intercept, the Thunderbolts pounced. Armed with 850 caliber Browning machine guns, the P-47 could deliver more sustained fire than any German fighter. Pilots like Francis Gabby Gabreski, Robert S. Johnson, and George Preddy racked up dozens of aerial victories, some surviving hits that would have grounded any other fighter. In air-to-air combat, The P-47 wasn't the tightest turner, but in a dive, it was nearly untouchable. Pilots used this to boom and zoom, dive from altitude, fire, and escape before the enemy could react. Even when outnumbered, Thunderbolt squadrons held the advantage. They could take hits, return fire, and get home safely. But their dominance didn't stop in the air. By summer 1944, the P-47 took on a second role: ground attack. Outfitted with bombs and rockets, it became the spearhead of tactical air power. Thunderbolts shredded rail lines, ammo depots, fuel convoys, and tank formations across France, Belgium, and the Netherlands. German soldiers nicknamed it the Jabo, short for Jagdbomber, and learned to fear the roar of its engine overhead. One German soldier, writing from Normandy, described the experience. "The Americans send these monsters in waves. They come from the clouds, fire everything they have, and are gone before we can aim. It is terror from the sky." After D-Day, Thunderbolts flew thousands of sorties per day. They attacked moving columns, reinforced bridges, and isolated German armor. The Luftwaffe, with shrinking fuel and pilot reserves, could no longer protect its troops on the ground. The sky, once Germany's strength, had turned hostile. By late 1944, the statistics told the story. Over 15,000 P-47s produced, 70 million rounds of 50 caliber ammo fired in Europe. Over 6,000 tanks, trains, and trucks destroyed. Thousands of Luftwaffe aircraft downed or denied airspace. More importantly, Thunderbolt units maintained operational tempo. A damaged P-47 could be patched and returned to combat in hours. German fighters, by contrast, sat idle for lack of parts, fuel, or pilots. One by one, Luftwaffe squadrons became paper units, existing in name only. Even advanced designs like the Me-262 jet could not stem the tide. Thunderbolts ambushed them at takeoff, strafed them on runways, denied them airspace. In the final months of the war, Thunderbolts continued to dominate the skies. Flying from captured airfields in France and Belgium, they ranged across Germany with near total impunity. Their presence meant supply lines were never safe. Movement by daylight was suicidal for German forces. Luftwaffe pilots began avoiding combat. Not by choice, but by necessity. Fuel shortages, ammunition limits, strategic paralysis. When Thunderbolts escorted bombers over Berlin in February 1945, few interceptors rose to meet them. The Reich was collapsing, and the P-47 was overhead, unchallenged, unyielding. It had become more than a fighter. It was a symbol of inevitability. The R-2800 engine, once studied nervously by German engineers at Rechlin, was now propelling hundreds of sorties a day across the collapsing Reich. Its thunderous roar echoed over cities, fields, and forests. Its payload brought destruction. Its resilience gave the Allies air dominance. And its design, mass-produced and modular, had crushed a precision-driven opponent with the brute force of strategic industrialism. By the time the war ended in May 1945, Germany had produced some of the finest fighter designs in the world, but they hadn't built enough. They hadn't built them fast enough, and they hadn't built one like the P-47. When the war began, the Luftwaffe was feared. Fast, aggressive, and well-coordinated, its fighters dominated the skies over Poland, France, and the Low Countries. German engineers took pride in their precision-built aircraft, each a symbol of technological superiority. But by 1944, that image was shattered. Because by then the skies over Europe belonged to American machines, and at the center of that dominance was the P-47 Thunderbolt, powered by an engine that told a different kind of story. Germany had mastered the art of building excellent aircraft, but only in small batches. The Messerschmitt Bf 109, Focke-Wulf FW 190, and even advanced designs like the TAR 152 were marvels of engineering. But they required skilled labor, specialty parts, and centralized facilities, all of which were vulnerable to Allied bombing and material shortages. In contrast, the United States had redefined military production. Aircraft like the P-47 were designed for mass production from day one. Each component of the R-2800 engine could be built in separate locations, shipped and assembled with minimal customization. It wasn't just a fighter, it was a product, one that could be manufactured in the thousands, repaired in the field, and flown by ordinary pilots. That was the difference. At the height of the air war, American fighter groups could rotate Thunderbolts through missions with astonishing speed. Ground crews could replace damaged parts within hours. Engines could be swapped in a single shift. Aircraft returned to flight lines in a day. German squadrons, by contrast, were bogged down. Replacement parts were scarce, fuel was rationed, engines required careful tuning. Attrition outpaced production. A downed Thunderbolt might be replaced from a stockpile flown in from England or Italy. A downed Bf-109 might mean weeks of delay. The Luftwaffe was bleeding. The US was replenishing. As Thunderbolts swept across Europe, escorting bombers, destroying rail networks, and cutting off retreating German units, the Luftwaffe shrank, not just in aircraft, but in capability. By mid-1944, experienced German pilots were gone. Many new recruits had under 20 hours of flight time. They flew aging aircraft with minimal fuel, often launched into hopeless battles against waves of high-performance Thunderbolts, backed by coordinated command and control systems. The old equation, superior pilot plus good plane, no longer worked. The Americans now had good pilots, good planes, and far more of both. The Thunderbolt's dominance wasn't just about combat performance, it was about who could keep fighting. Germany had spent years refining the art of air warfare. America had spent months building the means to sustain it indefinitely. The R-2800 engine was proof. A 2,000 horsepower monster that didn't need to be perfect. It just needed to be good enough to survive, and built in the tens of thousands. The Luftwaffe saw the writing on the wall. Its engineers, once confident that quality would triumph over quantity, now understood the battlefield had changed. The war was no longer just about flight. It was about production, pressure, and attrition. And in those terms, the outcome was already decided. When German engineers completed their final analysis of the R-2800, the war was already slipping away. The Luftwaffe was in retreat, bled dry in the skies over France, Belgium, and the Rhineland. Fuel shortages grounded more aircraft than enemy guns. Runways were cratered. Maintenance crews scavenged for parts among wrecks. But inside dusty workshops and shelled hangars, some of those engineers reflected on what they had learned, and they understood the true legacy of the P-47. The Pratt Whitney R-2800 wasn't just a powerful engine, it was a philosophy in metal. Where the German approach emphasized precision, the American approach emphasized resilience. Where the Luftwaffe optimized for performance on paper, the Americans optimized for combat conditions, mud, cold, heat, battle damage. The engine didn't need to be refined. It needed to start every morning. It needed to take bullets and keep running. It needed to be built by hundreds of workers who weren't engineers and still deliver 2,000 horsepower under pressure. It was a machine built not for showrooms or air shows, but for total war. After the war, many former German engineers were interviewed, recruited, or debriefed by Allied technical missions. Their verdict was consistent. They were astonished by the scale and simplicity of American engine design. Some even called the R-2800 barbaric brilliance. Not beautiful, but brutally effective. It changed how they thought about combat aviation. Because in the end, it didn't matter if a German engine produced 1,250 HP with a 30-minute service interval, if it couldn't be built fast, repaired easily, or survive long enough to matter. One German test engineer summarized it this way: "We built the violin, they built the hammer, but the hammer won." The R-2800 would go on to power not just the P-47, but also the F-6F Hellcat, the F-4U Corsair, and later commercial aircraft. It became a benchmark for reliability and endurance. Its influence shaped not only post-war engine design, but also a doctrinal shift in aviation thinking. Build for sustainability, not perfection. Engineer for recovery, not just peak output. Make complexity optional, not mandatory. These ideas carried into the jet age, influencing everything from the F-86 Sabre to Cold War bomber design. And for those who had fought against it, especially the Germans, it marked a humbling realization. The war in the air had not just been lost in the cockpit, it had been lost in the factory. The German engineers who once circled that captured P-47 in a cold hangar in 1943 knew what they were looking at, even if they couldn't admit it then. This wasn't just a powerful engine, it was a preview of what was coming. It was mass manufacturing with precision. It was war logistics taken to the air. It was the future, loud, oily, standardized, and unstoppable. And in a war where the Luftwaffe once prided itself on elite pilots and technical mastery, it was a painful final lesson. Power wins battles, but production wins wars. In the final months of World War II, the skies above Europe were no longer contested. They were owned, not just by the pilots who flew there, but by the machines that made their flight possible. Machines like the P-47 Thunderbolt and the roaring engine that drove it, the Pratt Whitney R 2800. To many German engineers, the defeat wasn't sealed in a single battle. It came slowly, with every captured wreck, every grounded squadron, every report of Thunderbolts returning from missions no other plane could survive. In that massive radial engine, they saw something they hadn't built. Not because they couldn't design it, but because they couldn't scale it. The R-2800 wasn't beautiful. It wasn't elegant. But it worked, and it kept working, again and again, no matter the fuel, the damage, or the weather. It was power made reliable. It was engineering made practical. It was victory made possible. And for every Bf-109 that was hand-assembled, there were 100 Thunderbolts built by line workers in Connecticut and shipped across an ocean without fanfare. That was the story of the air war in Europe. Not one of flashy duels or perfect design, but one of endurance, repeatability, and resolve forged into steel. Germany had built aircraft for pilots. America had built aircraft for war. And when the dust settled, it was the sound of a 2,000-horsepower radial engine, low, loud, and constant, that echoed over the ruins. A sound not of elegance, but of inevitable victory.